All right, ladies and gentlemen, good evening once again. Welcome to another session, our second to last of this semester. Remember that we still have a class to do on Sunday, so don't forget. And it's going to feel like school is closed now, but remember that we are behind in terms of the hours that we are supposed to complete, and also where I would like you to be, where I would like you to be for the term. All right. So we're gonna try to make use of whatever time we have, and then let us see what else we can do to make up. Okay. All right. Good. So let's jump into it. I have no announcements. I have no updates or anything like that. Remember, if you can, guys, please send me. In fact, you know what? Let me put my personal number in the group, because I think when you guys message me, you guys are not really getting me. I'm hardy on that device. So check the group, guys. This is my personal number. Check the chat. Pardon me. So that's my personal number. You'll always get an instantaneous response regarding your request when you message me on that number, okay? All right. The other number I'll respond, but occasionally just when I get a chance to check the school phone, I'll check it. All right, good. All right, so we are going to start a new topic tonight. And not necessarily like a new, well, I'm going to introduce you to algebra. As we had promised, I don't want the year to finish without you at least getting some scratch or some taste of algebra, right? On a Monday, we would have been doing the worded problems. We would have completed that last week. Last week, we would have completed that, right? And I would have posted some extra, well, I would have allowed you to take some screenshots of the questions. So you're a bit more exposed to worded problems. Now we're going to touch base on a little bit of algebra tonight. Are you guys seeing my screen? I think you should be.
Yes, sir.
Yes, sir.
Okay, good. Now I will be uploading. I'm not sure if I spoke to you about this. I will be upload the test that I would have given you tonight if we had enough time, and whatever tragedy that struck in October didn't strike us, then you would have been getting an online assessment tonight. However, because of time constraints and we need the hours, we need to make up back for the teaching. The assessment that you would have been getting, I'm going to upload it sometime Saturday, and you guys are going to have up until Sunday to do as much of the question as possible and upload it to Google Classroom. If you would like a review, like I said, you can use it as practice if you want to, or if you want to do it and then get back a review based on what you have done, then you are free to do so. But there's going to be a portal that's open for 1 day, right? If that portal closed, then you can, I don't know how you're going to get the results to me. All right. Or if you want, you can pass and drop it off down by the school. All right. So that's just up to you. But as it relates for tonight, we're going to focus on getting across some algebra concepts. All right, here we go. All right, so we're not going to go into the nitty gritty and the breakdown and the this and the that. We're just going to go through some fundamental concepts related to algebra, right? What exactly is algebra? We're not going to go into the history either. We're just going to try to get to the meat of the matter, trying to get you to understand some basic fundamental principles of algebra. All right. So I want to start off tonight by talking about a few terms that you're going to commonly hear me talk about in this topic, right? And so, assuming, and this is a wild assumption, I'm gonna assume that you would have heard about the topic algebra. You would have maybe seen it somewhere on a piece of paper. It has to do with simplification and simplifying algebraic expressions and solving equations. I will know say hold for x and y and a and b and all that stuff. but there's a lot of ambiguity that surrounds the concept of algebra. First thing that I want you to learn, guys, is algebra is not a concept that is going to be, it's not something that you're going to learn that may necessarily apply to real life. There's aspects of it that we will use and apply to real life. However, algebra is really an abstract aspect of mathematics, right? It's an abstract branch of mathematics. And when we say abstract, it's more like an idea rather than a situational topic, right? So it's not like, for example, measurement, where we know in real life you'll have something to measure. You may have to measure the area of the floor that you're going to put in your house. You may have to measure the perimeter of the fence that you're going to put around your house. It's not like say for example trigonometry, where you're going to have to calculate angles and in real life. Algebra is more on the abstract side. You can look at what the word abstract means, right? So it's more on the abstract side where we're trying to create a relationship. So basically what we're trying to do when it comes to algebra is that we're trying to create a relationship between something we know and something we do not know. Trying to form a relationship between them. And so what we know becomes our result, or we call it the known value. And what we do not know, we assign a particular letter to it. So the unknown, we use various letters like X, Y, A, B, P, Q. In fact, I can use any letter of the alphabet. But when it comes to algebra in textbooks, formula books, practice sheets, you're mainly you are going to see X and Y, A and B, P and Q being used to derive the example, not derive, but to formulate examples. So I wanted to get used to the idea of using the letters X and Y, A and B, P and Q, but it can be any letter, and throughout my examples, I will create some variety in terms of my examples. I won't just use X and Y, A and B, P and Q. I'll use other letters as well to bring across the lesson. All right? So in a nutshell then, in one sentence, algebra is where we try to create a relationship between what we know and what we do not know. And then we use what we know to help us to find out what we do not know, if that makes sense. Now, there is two branches of algebra, right? And remember, guys, this type of lesson, this is a compressed type of teaching. So I'm leaving out a lot of important details, but I'm telling you the most important ones. Now, when it comes to algebra, there's really two branches that we're looking at. Two branches, right? There's a branch known as the expression branch. And the other branch is called the equation branch. So there's two broad topic or broad subtopic on the algebra, right? The branch where we talk about expressions, and under expressions, what we do is that we do a lot of simplifying. We do a lot of simplification. And under equations, we do a lot of solving. So mainly under equations, you're going to be finding out what the result of something is. So solving. And under expressions, you'll find out that we do a lot of simplification and a lot of expansion. So we're going to be learning different techniques of how to simplify various types of expression, how to expand different types of expressions. That's mainly what we're going to be doing. Now, in order for us to create a relationship between these two, give me a sec, we have to have an understanding of what is an expression. Before we can even talk about equations, and we don't want to mix them up because a lot of persons will get an expression to simplify, and subconsciously they'll refer to the expression as an equation. So the first thing that we want to look at here is what is the difference between an expression and an equation? What's the difference between an expression and an equation? They are pretty much the same. It's just that with an equation, there is going to be involved an equal sign. Or it could be what is called an inequality sign. Less than, greater than, less than or equal to, greater than or equal to. Checking the group to see if there's nobody. An equal sign, we know it's that symbol, right? And with an inequality sign, we have less than, greater than, less than or equal to, greater than or equal to. With the expression, there is none of those signs are there, right? Simplification is like breaking something down to its lowest form, to its simplest form. So we talk about simplification, we're referring to breaking something down. So breaking down to simpler form. Solving is where we're actually getting a result for the unknown. So maybe we want to find the value of x, result for the unknown. So maybe what we want to do when it comes to an equation, what we're trying to do is that we're trying to find the value of the unknown. What is the value of x? What's the value of y? What's the value of a? What's the value of b? What's the value of t? What's the value of t, q, r, p, whatever? We want to try to find out what is the exact value that represents this particular letter. With an expression, we don't really care about that. What we care about is writing the expression or writing the equation in its simplest form. For example, if I have something like 2x plus 4x, sorry, 2x plus 4y plus 3x plus 5y, that's a long expression. But I can simplify this by adding these two x's together and adding these two y together. So we can say 2x plus 3x is going to give us 5x, and 4y plus 5y gives us 9y. So 5x plus 9y is a simplified version for 2x plus 4y plus 3x plus 5y. So that's kind of like what we're going to be dealing with. Now, before we can get into all of this x and y and a and b and all of that stuff, we have to really latch on to something known as, you have to latch on to something. Oh, sorry, if you guys are writing, my bad. Not sure if you guys are writing, you can screenshot. I'm not sure if you're writing while I'm teaching, I'm not sure. But there it is, you can take a screenshot if you want to. Now, before we can get into all of that, let us first zone in on what exactly is an expression. What?
Sir, just scroll back a little bit. I didn't get a chance to take the pic.
Good to go?
Okay, yes.
So we're going to look at what is an expression? What does this thing look like, right? So what is an expression? Well, in a nutshell, not to make things complicated, to make it as simple as possible, an expression is basically, well, an expression contains three parts. Let's put it this way. An expression contains three parts. It has something known as a coefficient. It has something known as a power or an exponent. And we also have something else known as a variable, which we sometimes refer to as a base. Let's look at it. So what exactly is the coefficient? Well, the coefficient is the number, let's write it out in words. The coefficient is the number that appears in front of the variable. The exponent or the power is the number that is above the variable. And this is not the numerator, it's a very tiny number. The number is smaller in appearance. Not smaller in quantity, but small as in, we're going to see it shortly. So it's the number that is above the variable. And the variable is the actual letter. So the variable or the base is the letter. So it's the letter, put in bracket here, S. So it could be letter, it could be a letter, or it could be letters, right? That represents the unknown quantity. So when we look at an expression, then when it comes to algebra, what you're going to be seeing, and I want to write something very simple, right? What you're going to be looking at is something like 3x squared. Let's keep it simple. This entire thing here is called an expression because this number here is your power. This number here is your coefficient. And this thing right here is called the base or the variable. And when you put them all together in one, it is called an expression. It's called an algebraic expression. So the number in front is called the coefficient. The little number that's attached here, that number can be a fraction. It can be negative. It can be positive. It can be a decimal, which it won't be, but it can be a decimal. And then that variable there where you see as x, it can be y, it can be a, it can be b, it can be p, it can be q, it can be r, it can be s, it can be any letter of the alphabet. Now, what confuses many students, even if you're doing maths for 5 years, I've seen many students, no matter how good they be at maths, they get stuff like this incorrect. For example, when you see x, many students refer to x as being 1. Now, as instructors, we know what you mean, but what you're saying is not reflecting what you're saying is not reflecting the meaning. For example, a student will say, sir, my teacher told me that x is 1. The teacher never actually said that. What the teacher said was that the coefficient, or the teacher should have said the coefficient is 1. X can't be 1. If x is 1, then what is A? What is R? What is T? What is B? What is Y? If x is 1, then each of those letters have to represent a number. So how are we going to know what number they represent? They don't represent a number. So technically then x is not 1, but the coefficient of x is 1. The power of x is 1. So when you see the letter x, we'll say in our language when we're talking that, oh, sir, x is 1, or x represents 1. No, x does not represent 1. The coefficient of x is 1, and the power is 1. So when you see something like negative x, what does that mean? Negative x means that it's negative 1x with a power here. Now, if you have a letter or a variable, right? A variable, which is a letter, same way, right? Yeah, I'm not going to use the word letter. I'm going to use the word variable. Letter and variable means the same thing. When you see a letter, that doesn't have a number in front of it, that number is understood as being the number. When you see a letter by itself without any number in front of it or above it, the number that is understood is 1. Right? So the number that is in front of x is 1. The number that is in front of, that's above x is 1. And that goes for every letter. So if you see the letter T, what does this mean? It means 1T. When you see the letter V, what does that mean? 1V. When you see the letter Q, what does that mean? 1Q. The power of T is 1. The power of Q is 1. The coefficient of Q is 1. The coefficient of V is 1. The power of V is 1. So when you see a letter by itself, we are not going to put the 1 there. 1 is the only number that you generally do not see in algebra, especially under the concept of expressions. We never, ever, ever, ever write the number 1. We'll write 2, we'll write -1, and not even -1 you're going to see. You're going to see a negative, but you won't see the 1, because the number or the coefficient is understood. All right? So if I say add x plus 3x, what does that mean? It means add 1 to 3. But you're not going to see the 1. You're just going to see x, and you're going to have to understand that the number that is in front of x is 1 automatically. So when I say what is x plus 3x, your answer is going to be 4x, because this is 1 plus 3, which is equal to 4 along with the x. And if you see something like, -2, if you see something like negative x plus 5x, what does this mean? It means -1 plus 5. And we know by now that -1 plus 5 is equal to 4x. -1 is an amount that you owe. 5 is an amount that you have. Pay what you owe, or you still have 4 left. So that would be negative. That would be positive 4x. So don't expect to see the number 1 at any given point during your algebraic simplification, whether in live classes or not. You're not going to see it. You're going to see the letter x.
Excuse me, sir.
Yes, go ahead. Question.
We have a couple students in the waiting room.
They're late. All right, lovely. Now, for those who are just joining us, please take a screenshot. We've just been doing discussions. Remember, I started the class exactly at 7:02. So if you've been in the waiting room for a while, I didn't know. Remember that the login time is 6:45, so take a screenshot. That's what we've done so far. Just been a bunch of talking and discussion. If you're just joining, go ahead and take a screenshot. All right, now, where algebra gets a bit confusing for many persons, right? No, what we just discussed a while ago with that variable representing 1, or the coefficient of the variable being 1. That's not the only thing that confuses people when it comes to algebra. What confuses a lot of persons is that they believe, or they have this concept, or there's this false rumor that goes around for years and it becomes so pandemic that in mathematics we add letters. Rubbish. We don't add letters in algebra. In real life, you can't do it, so I don't see why it's possible to do it in math. We don't add letters in math, ladies and gentlemen. We add the numbers that are in front of the letters. We multiply the numbers that are in front of the letters. We divide the numbers that are in front of the letters. We subtract the numbers that are in front of the letters. We don't interfere with the letters. There's aspects of it where we have to play around with the letters, but we cannot add letters in algebra. Now, before we get into the addition and the subtraction part, let's look at something that confuses people a lot when it comes to algebra, right? Let's start off with something simple. What does this mean? 2x. When you see 2x, what does that mean? This means 2 multiplied by x. Let's use y because my times sign and my multiplied sign looks the same. So let's do 2y. What does this mean? 2y means 2 multiplied by the letter y. So if I know what the value of y is, then I know what 2y equals to. Because if y is 4, then 2y is 8. If y is 5, then 2y is 10. If y is 20, 2y is 40. Whatever y is, I'm going to multiply that number by 2. What does 3t over 4 means? What does that mean? When people see that, they're confused then. Now, there's two ways to imply this, right? You can say this means 3 times t, and then the results divide by 4. Or you can say this is 3/4. You can say that this is 3/4. What's happening with my screen? Hold on. So when you see 3t over 4, it means two things. It means you're going to multiply the value of t by 3 and then divide the result by 4. Or you can say that it's 3/4 multiplied by t. However you want to interpret it. It can be 3 times t, and whatever t is, you're going to divide the result by 4. Or you can write down the value of t and find 3/4 of that value. That's what 3t divided by 4 means. Now, when you see something like this, then let's say you see 5a to the power of 4. What does that mean? People say that, people like, oh, it's so difficult. You know, can't bother with the whole part of different letters and it's confusing. Let's look at what it means. 5a to the power of 4 means 5 multiplied by a, multiplied by a, multiplied by a, multiplied by a. So a to the 4 means that you're multiplying a by itself 4 times along with multiplying by 5. So if I know what the value of a is, I'm going to multiply that number by itself 4 times. If a is 2, it's going to be 2 times 2 times 2 times 2 times 5. So 5a to the 4th means 5 times the a 4 times, or 3 times, whatever the number may be. We're not going to get into the negative ones and the fraction ones. That's a whole different story. We want to keep it simple for now. So when you see 2y, it means 2 times y. When you see 3/4 t, it means 3 times t divided by 4. When you see 5a to the power of 4 or 5a to whatever number, then it means 5 times the letter that amount of times. Now, there are going to be some expressions that kind of throw you off a little bit. For example, let's say when you see something like x squared y 4. What does that mean? X squared y 4. Oh my God, it's so difficult. X squared y 4 means x times x times y times y times y times y. It's x times itself 2 times and y times itself 4 times. That's what x squared y 4 means. When you see letters and numbers joined together in algebra, it means that these are the relationship between the letters and the numbers. The relationship between the letters or the letter and the number is multiplication. If you don't see a sign like an addition sign or a subtraction sign or a division sign, then it has to automatically be multiplication. If there's a square root there, you're going to see square root of x. Or it's going to be the cube root of y. So if you don't see anything that's between or separating the letters, it implies multiplication. And in fact, let me just go ahead and write this down. Square root of x means x raised to the power of a half. And cube root of y means y raised to the power of a third. So you see them look at something here that I have on screen. This is what makes algebra look challenging because a lot of persons don't really understand what these expressions mean. If you understand what it means, it won't scare you. Now, another thing that I realized, teaching math for a long time, a long time within the game, Another thing that baffles students is the rules surrounding algebra. And it's not a lot of rules, It's a few of
Sir,
them.
go back to a bit, please. Okay, sir, thank you.
Okay. Now, what baffles a lot of students is the rules surrounding algebra when it comes to what can I add, what can I subtract, what can I multiply, what can I divide. And the rules confuse students. Mathematics is a subject that follows a particular principle. It follows rules. People don't really like follow rules. I don't like follow rules. Nobody likes to follow rules. If they can bend the rule, they will. In math, that doesn't work. You break the rule, you're punished by getting the question incorrect. So the rules are the rules and they must be obeyed. If you don't obey them, you're going to have a problem. No. One of the fundamental principle of the rules is understanding the categories of these expressions. Now in math, we categorize the variables in groups. We call them the like group, or some persons say the like terms, and then we have the unlike terms. So when it comes to the like terms, let me check the group again because there might be persons who are late. It's one more person there. So when it comes to the like terms and the unlike terms, let's put them under T. Categorize them so you can see them clearly. Hold on. Undo that. Undo that. When you put them under category, maybe you can see them. So what are like terms? If I write x, 2x, negative 4x, half x, why do you think I call these like terms? Because all of them have what? X, 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 X. Even though the numbers at the front is different, because this is a positive whole number, so even though you know that this is 1, this is 2, this is negative, this is fraction, one similarity between these terms is that the terms all have an x. Let's write some more. Five y squared negative 2y squared 0.7 y squared 2/3 y squared. Notice the numbers at the front is what? Different. One are 5 positive, one are 2 negative, one is a decimal positive, one's a fraction positive. But what's similar between all four terms that I've written here? What's similar is that they all have the same variable, y squared. So they all have a y squared, y squared, y squared, y squared. That's what makes the term fall under the like category. So anybody that you meet upon in the future that has a y squared, they belong to the y squared family. All right, let's make it real. 2t squared x, a quarter t squared x, negative 5 t squared x, 4t squared x. They all have different numbers. This is 2, this is a quarter, this is -5, this is 4. But what's similar between them is the fact that they all have t squared x, t squared x, t squared x, t squared x. So this is what I think scares people, the fact that there is so many different combinations of algebraic expressions. When it presents itself on paper, it does corrupt people's mind. And they start to say that math is difficult or algebra. What's difficult is what makes a term like. If you know what like terms are and you know what you can do with them, then you're safe. Now look at unlike terms now. Self-explanatory. If something is unlike them, different. So if I write 2x 3t minus 5r half v. All of them terms are unlike. You have the x family, the t family, the r family, the v family. So they are unlike. That's very self-explanatory. So you have to understand what can you do with these. You really can't do anything with them, you know. But I'm just saying, what can we do with them? All right, let's look at some trickier ones then, right? Because Mr. Peter like him. Pardon me? Oh. Let's do some more examples. Look at some trickier ones. Because Mr. Peter teaches and make it look too easy. Can't so easy. I'm telling you, it's as easy as this. All right. Let's look at this one. Let's say we have 5x. Yeah, let's use a. Yeah, man, I haven't used an a as yet. So let's say we have 5a squared. Let's say we have -2a cubed. Let's say we have half a, and let's say we have 0.5 a to the fourth. Are those terms like or are they unlike? Look carefully, you know. Don't guess. Are they like or are they unlike? And if you say them like, tell me why. And if you say them unlike, tell me why. Somebody, anybody. Are they like or are they?
They're unlike because the powers are different.
Very good. They're unlike because the powers are different. For the terms to be the same, notice over here. Look over here now. You know. 1, 1, 1, 1. 2, 2, 2, 2. T squared, t squared, t squared, t squared. X, 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 x. So if you notice over here, even though I wasn't talking about it, you know, what makes them like is not just the letter, but the powers that are attached to the letters as well. They all have an a, but each of these a is raised to a different power. This is a squared, so it belongs to the a squared family, a cube, a, and a fourth. This belongs to the a family, the a fourth family, a to the 3 a squared family. So that's what makes them unlike. If you cannot identify the terms that are like and unlike, you will have a real problem in algebra. All right, let's make it even trickier. Mr. Peter, all right, let's make it even harder then. 5. Why do I keep using 5? What is me and 5? I buy 5 tomorrow in a cash pot. Don't know what is me and this 5. Every one of my example, them have 5 night. 5 yes so. 5 yes so. 5 this so. 5 this so. Oh my lord. All right. 4 x squared 9 y squared 2 t squared 7 b squared. Are they like or are they unlike?
They're unlike.
Why? What's the main reason why they're unlike?
The letters.
The letters are different. So even though the powers are the same, because that people we use that and try catching enough time, we make the powers them the same to try tricking them, but the variables are different. And in example number 2 there, we make the letters them the same, but we make the powers them different. So what is the conclusion can we draw from this? We can draw a conclusion to say that what? For a term to be categorized as being like, both the variable and the power must be the same. We're not business about the number with the in front. We just care about the variable and the power of the variable. Those two must be the same for them to be categorized as being like. If there's any difference between them, they're unlike. Now look at this nasty one now. This one that makes everything just look corrupt. This makes algebra just look corrupt. Look at this now. Half a squared b 2ab squared negative 3a squared b squared 0.5 ab. They all have an ab. But why is it under the category of unlike? Can anybody tell me why we categorize those terms as being unlike?
Yes, sir.
Go ahead, listening. Yeah, go ahead, tell me why you think it's unlike. What about trick me or trick you?
The powers fall on the different letter.
Exactly. Very good. So for this term, the a is squared, but the b is not. For this term, the b is squared, but the a is not. For this one, both of them have a square. And for this one, none of them has a square. Yes, they all have an AB, but the powers are different on each of the letters. So that's what makes them unlike. So when you look at the screen now, if you back away from the screen now, if I never tell you all of these things in this class, when you see this on screen, this will confuse you. Okay, like so much letters, X and Y and T and A and B and P and so confusing. It's a lot. But you have to understand the principles behind the algebraic terms. What makes them like and what makes them unlike. All right? Open up the floor for any questions before I move on. Silence means you're good to go, And that silence means, So if I don't hear any question, I'm going to assume that everyone understands. Going once. Going twice. Sold. Everybody understand. Let's move right along. Now time for the rules. So here are the rules then. Obey them. Break them, you have a problem. So to simplify this, right? Simplify this. When it comes to the addition and the subtraction rules, when it comes to the addition and the subtraction rules, we can only, you know what? Because I go make sure I write this word only in all caps, We can only, not just only, we can only add and subtract come on, Mr. Peart. Like terms. So that's all we can do, guys. When it comes to adding and subtraction, we can only add and subtract the terms that are alike. So what that means? If we can only do that, that means you cannot add or subtract terms that are unlike. All right. I'm going to put a note 12 here. Note 12. We add / subtract the coefficients. Every time I teach this topic, I have 1 or 2 students that escape and spread bad rumors about mathematics, saying that sir teach us how to add letters. I never do that. I'm saying to you, we add or subtract the coefficients, the numbers when they're in front of the letters. We don't interfere with the letters. All right, let's look at some example. I don't want to emphasize too much. Because you're not, you're the sacrificial lamb, Other students hurt my feelings. We take it out my own. All right. Can we add this too? What would be the answer for this? What is 2x plus 5x?
7x.
7x.
7x. Not true? Because we not add the letters them, people. We are adding numbers them, right? So the 2 and the 5. And then we just rewrite back one of the x. We don't need to write back 7xx. It's just 7x. So we have 2 x's, and we add 5 more x's on the 2 x's we already have. So much x we have now in total? 7 x's. So 7x. Not true? All right. Can we do this? (3x). Why do I keep using 3?
Sir, one of your students got bounced off.
But can we do this? Can we subtract 2y from 5y?
No, sir.
I have students in here that tell me this is 3xy. Not in here, no. Students that I've taught. After you go through the lesson with them, them still tell us say 5x minus 2y is 3xy. Ladies and gentlemen, for crying out loud, if you are able to subtract 2y from 5x, that means you're telling me that you can subtract one apple from one banana. I don't know how you're going to do that. There's no way you can cut out one apple from one banana, or vice versa. 2y belongs to the y family, and 5x belongs to the x family. You cannot subtract the letter y from the letter x, and you cannot add the letter y to the letter x. So in other words then, sir, what's the answer for 5x minus 2y? The answer is 5x minus 2y. There's no answer. We're not going to give you that to do because we know it cannot be done. We're going to give you a mix-up expression and say simplify it. But if you happen to get an expression where nothing is alike and you can't group anything, leave it alone. All right, let's look at this one. What is negative 8x plus 3y? Sorry, negative 8x plus, sorry, not x. Keep using x. I promise you I was going to use different letters. What is negative 8a plus 3a? What's that answer?
5a, sir. That's 5a.
Negative
sure?
5a.
Negative 5a.
Minus 5a.
Negative 5a. I have students that tell me that the answer is negative 11a. Remember, we talked about this now. Remember, look, if I remove the a from here and the a from here, doesn't this look like the very first class I taught you when you met me? Negative 8 plus 3? Yeah. So
Yes,
by
sir.
me attaching the a here and the a here, what difference does it make? I see what you're doing. It's just that it's been represented in an algebraic form. So what then is this answer then over here? What is 5? What is me and this 5? No, sir. I swear. No, man. No, we have to start with the number near 5. For evening, 5 again, 5 again. Ah, too much. Hey. What is negative 90 plus 4s? Can you simplify that any further?
No, sir.
No, you cannot go any further. Negative 90 belongs to the T family, and 4s belongs to the S family, so you cannot add or subtract them together. Now that we have a basic understanding, then that, okay, then, so sir, the terms have to be alike for you to add them. If I give you this to do, what is 10x cubed plus 3x squared? Can we add those together?
Nope.
Why?
Because the powers are different.
The powers are different, so we cannot add them. However, what is minus 3x squared plus 4x squared?
That is x squared or 1x squared.
And we don't write 1, not true?
And we don't write 1, so that's x squared.
No time, so the answer is just x squared.
X squared.
Negative 3x squared plus 4x squared. I owe 3x squares, and I have 4. And I pay the 3x squares that I owe. I'm instead have 1 left out of the 4 we have. Can we just minus 3 out of it? So we have 1x squared left. So again, more emphasis on the fact that what? The terms have to be alike for you to add and subtract them. So what happens now, ladies and gentlemen, is that when you get a question now that says, look at what it's going to say. It's going to say, simplify. That's the verb we use in mathematics at this level. Simplify. 5x. Oh, Jesus, have mercy with this 5. 11a minus 3b minus 10a plus 4b. When you get an expression like this, you can't just go ahead and take the 3 from the 11. Because one is b and one is a. And you know, so you can only do the terms that are alike. So what you do now is that we use something called a GLT, a group-like terms method. Now, some persons will be advanced enough to do it in their head mentally, and that's fine. You can do that. No problem with that. I really appreciate that, by the way. But if you're not 200, take a little time where you say, all right, 11a minus 10a minus 3b plus 4b. And they get D with the thing. Now, I have some students in here, them experience, them go through the whole rigorous training of doing mathematics. Mathematics beat them bad. So they'll come to my class with some ambiguities. So when I move this 10a from here, this negative 10a, some students will say, then sir, when you move the 10a, it's not supposed to change sign. This is not an equation. So I have students that when they move a certain letter, them change the sign. Do not change the sign. Rearranging is different from transposing. We are not doing equations, so no sign now going to change nowhere. No sign is not going to change. So if you notice that when I move the 10a, I move the sign with the 10a as well. So I wrote down my 11a right here. And let me just slide the 10a right there, so. Slide the 3b right here and put the 4b right there. So that's what I did. So me just organize up the thing properly and me keep the signs in the same. I can proceed to say 11a minus 10a is going to give me a. If you want to write 1a, that looks weird though. We don't write 1 in algebra. You're never going to see me write 1. If the answer works out to be 1, me just write the letter alone. A. So A, and then now minus 3b. I still have persons here that writes negative 3b plus 4b is negative 7b. Stop it. Negative 3b is you owe 3 b's and you have 4 b's. So you can pay the 3 where you owe. And then pretty much you have 1 b left. So the answer is A plus B. And A plus B is not C. I have so many students that do that to me. They hate math so bad, they make a laughing stock out of it. A plus B is not C. A plus B is just as it is. A plus B. It's like 1 apple plus 1 banana. An apple plus a banana does not give you an apple banana. There's no fruit name, so. You have 1 apple and 1 banana is equal to 1 apple and 1 banana. Do you guys get it? Any questions?
Yes, sir. Because I got told, the one that you have the 3x squared plus 4x squared equal x squared. Can you go over that one, please?
Sure. The negative 3 is the amount that you owe. And the 4 represents an amount that you have. Go back to class 1 fundamentals. If you owe 3, if you owe me $3, you check your purse and you have 4. Can you pay the 3 that you owe me? Yeah, you can. And by paying this 3 out of the 4 that you have, how much you have left? 1x squared. Got it?
Okay, so when it's 1x squared, you can just put x squared. You don't have to put the 1.
Yeah, we don't use the number. We don't write the number 1 in algebra. Never.
Oh, okay.
Nowhere on the internet you'll go and see any teacher or any instructor write the number 1. It's the only topic where you don't see the number 1 at all.
Okay, sir, got it. Thank you.
Yeah. Nothing wrong if you write 1a plus 1b, you know, or 1x squared. Nothing wrong, you know. You can still write it. It's not wrong. It's just, it just look good. So we don't write it because it's kind of, what would I say, understood. All right. All right. So that's basically how you deal with adding and subtracting terms. Now,
Is there a
trouble is
question?
yes, question. Yeah.
Right. You see how you have 3b plus 4b right there?
That's
Or
not
negative
3b.
3b?
That's negative 3b, right? Uh-huh.
What if the answer right there you had if after work those areas all the answer was supposed to be negative, how would you write it?
If the answer, if you had worked it out and the answer would have been negative,
Yeah.
just write negative b.
Okay.
So if it was, say, for example, plus 3 and minus 4, you write negative b. 3b minus 4b, I have 3, but I hold 4. So if I pay the 3 that I have, I still got owe 1, so I owe 1b, which is minus b.
Okay. Just want to make sure of this. This when you're writing about the answers, want to make sure of the sign that comes down between the answers.
Yeah, it just depends on the outcome of the two numbers. What's the end result of the two numbers when you do the calculation? That
Okay.
sign comes down, yeah. All right. So that's clear, right? You get the understanding, say, once you have a mix of different terms, you have to put the ones that are alike beside each other, then you can compute the addition or subtraction process. If they're scattered all over the place, then you have to organize them, right? And there are going to be cases where you have more than, for me, I'm just keeping it simple now with 2 terms, but you can have an expression with 3 terms. You can have 11a minus 3b plus 2t minus 9a plus 7b minus 3t again. So you can have 3, but for now, we're keeping it simple. Because once you get the idea of the basics, no care how advanced you want to set it, it cannot become hard. It's just going to be more terms to deal with. But we know that once you have terms that are scattered, then you just group them together. I'm going to give you one to try before I move on. So give this one a try. Because these questions really, they come up a lot, but they don't come as a direct question. You find them coming in other topics as well. So let's see. Try this one for me. Simplify, and I'm only giving you a minute and a half. Simplify 2x squared y plus 3xy squared minus 4x squared y plus 5xy squared. Go ahead and simplify that expression for me. I'm only giving you a minute and a half. 1:30.
Sir,
Go
I'm
ahead.
not seeing the thing is over the last one.
Yeah, I'm gonna move it. I'm gonna move it.
So you have to give me more time.
Ah. So you should be either on your way to your answer or you get the answer already. So your answer should be negative 6x squared y plus 8xy squared. If you got it, thumbs up.
Sir,
Let's look at what
wrong?
the answer.
One
You go find
XY. What did I do wrong?
You go find
Now, one
You go find
XY
You go find
plus 9XY.
Let's see. Tell me if you have this. Negative 2x squared y minus 4x squared y plus 3xy squared plus 5y xy squared. Do you have that arranged like that?
First part incorrect. That's what happened. That's my mistake.
Gotcha. And then from here now, you owe me 2 or you owe me 4, so you end up owing me 6. And then now you have 3 or you have 5, so you end up have 8. And you can't go any further because those two terms are unlike. All right, so if you got it right, thumbs up, good job. All right, and that's the idea. That's the fundamental principles of adding and subtracting terms, right? It
Sorry,
cannot
I
get
put this square at the wrong X at the 5. Should got
Oh
the
yes,
Y.
that's true. Yeah, that's true, right? So thank you. Thank you so much. And that's it. You can't try to push this any further because the terms are unlike. Cannot add them, subtract them, can't do anything to them. All right. So that's the idea. And you're gonna see this popping up a lot. You're gonna see it pop up in equations. We have to go group the terms them according to like terms. Right? So you group A's with A's, B with B's, numbers with numbers, squares with squares, cube with cubes. That's gonna happen.
I'm sorry, sir. Can you go over that for me, please?
Which part of it? The second line?
Yes.
If you look at the term, this has a x squared y and this has a x squared y. That's why they're both beside each other. Both of them are x squared y. These are the ones here is a xy squared. This is a xy squared. So that's why we put both of them.
Okay. I totally overlooked that.
Yes.
Alright.
So once you can get the terms that are exactly alike together, then you can process the addition and subtraction aspect. Other than that, you can't. So for this one, we can't go any further because this first term here is x squared y, and this one is xy squared. So you're stuck. That's it. All right. Any questions? We're into our last hour of class. Any questions?
No, sir.
All right. So I'm going to show you something now. Look at this. When you want to find practice questions, you don't necessarily need me now, right? You don't need me. You just have to be resourceful. So look at this. Let's go again. ChatGPT makes your guys' life easier. You go ChatGPT. Okay? You go on ChatGPT, click on here. And then what you do is ask ChatGPT, here we go. Can you prepare 20? But that's 20. It can be 10, 5, whatever you want. Can you prepare? Okay. Can you prepare 20 addition and subtraction? Can you prepare 20 addition and subtraction of algebraic terms modeled terms, modeled from the Csec syllabus, Csec math syllabus. Now, when you ask ChatGPT this question, it might give you some random stuff. So what you want to do is that, can you prepare 20 advanced? You want to kick ahead. If you don't ready for the advanced version, ask them for some intermediate one. So can you prepare 20 advanced addition and subtraction of algebraic terms modeled from the CXC math syllabus? Boom. There you go. Lovely. See that? Lovely, ladies and gentlemen. You don't need me, guys. There you go. There are some nice ones there. Not true. Some nice little ones there. So see, you have 7x minus 3y plus 4x minus 9y. Mash up that quick and fast. 12a minus 5b minus 8b plus 3b. Mash up that quick and fast. As you go down now, it's going to get a little tricky because you have some brackets now. So I've shown you how to deal with the bracket ones, right? But you're going to get there. So you just do the ones that you can do. And what you can do is just, and then more challenging expressions here. 4x minus 3y plus, these ones have somewhat brackets involved. So you would have to learn the distributive law, right? How to deal with the distributive law to get that one, right? Some nice little examples are here. And I say, if you like, I can also provide you with work solutions. Just say, yes, thank you. What's going on here? Oh, it says if you need work solution, printable worksheets, exam style questions with marks and answers, CTEC paper 1 and paper 2 format, just let me know. I'll be happy to help anytime. Yes, please. There you go. See them work it out for you then? Yes, and don't make it pile up on you, ladies and gentlemen. When you get the chance now, you say, all right, before 30 to our next topic, we need to lick down them off quick and fast. Quick and fast. And knock them off. And you don't have to do 20. 20 is a lot. You don't need 20. You just need like 8 of these and you're good to go. All right, ladies and gentlemen, use up your resources. Okay? Lovely. My boss today. Should have shown them secret there, no man. So don't make it pile up on you with algebra. Master it from now. Don't pile up on you. All right, good. Now, trouble is knocking at your door, ladies and gentlemen. Trouble is knocking at your door. Mr. P, what do you mean by that? Because you're about to learn another version. But this time, no, you're not going to learn how to add and subtract. You're going to learn how to multiply and divide. And this is where I tend to lose some of my students. So hold on tight, ladies and gentlemen. Hold on tight. Are we ready? Wanna answer me?
Yes, sir.
Here we go. Now, the rules for addition and subtraction. Remember when we were adding and subtracting, ladies and gentlemen, we were only focusing on the numbers that were in front of the variables. You know, so we never interfere with the letters any at all. You know, so we never touch the letters, none at all. Only thing that we did was just add and subtract the numbers that were in front. When it comes to multiplication and division, not only do you have to deal with the numbers at the front, but you also have to interfere with the powers as well. That sounds very complicated, Mr. Pierce. Can you break it down simpler? Yes, I can. All right. So here are some rules. Okay. Rules again. We don't like rules, you know. Rules. When, see, I not even want to type it and I want to write it with my hand. When multiplying algebraic terms, when multiplying algebraic terms with the same base, so I'm gonna put with the same base in green. With the same base, we add the powers. I'm gonna say I multiply, we are multiplying now. So you're gonna end up seeing some unlike terms joining together. But this is multiply and divide. So we're not gonna watch the unlike terms anymore. It's gonna look like some of the terms are unlike. But they're gonna be unlike, they're gonna be like because of the base, not because of the power. So when the bases are the same, notice when we say when the base is the same, not when the expression is the same, you know. When the base is the same. Now remember, with an expression, you know, these are the base, you know, these are the power. When you put them two here together, it becomes the expression. All right. When dividing algebraic terms with the same base, we subtract powers. So multiplication evokes addition and division evokes subtraction. I'm still not clear. Mr. Pierre, can you give us some examples? I can. Keep them simple. Once you keep them simple, everything is good. Look at this now. Example 1. X3. No, let's put some numbers in front. No, I make 2 easy. 2x cubed multiplied, not adding up, multiplied by 3x4. I know you're going to say, Mr. Peart, you can't multiply that because the terms are unlike. Nope, you can. You can multiply it because of the rules for multiplication, them say you're going to add powers. So what we do is we take the 2 and we multiply it by the 3. You don't have to write it down like that. You can just say 2 times 3 is 6 and write down 6, right? And then now there's 2 x's. I don't need both of them. I'm just gonna write 1x and I'm gonna add the powers. Like that. So we take the 2, watch the pattern, guys. Don't make it confuse you. I took the 2 and I took the 3 and I wrote them in a bracket by themselves. Again, you don't have to write it down like that. You can just work it out in your mind and write down the value. So I could just write down 2 times 3 is 6. I could do that if I wanted to. But I'm just teaching from the basic point of view here. So I took the 2 and the 3, put in a bracket. There is 2 x's. I don't need both of them. I just need 1. One of them will represent both. And what I do is that I took the power from this x here and I added it to the power over here. So my final answer becomes 6x to the 7. Is there any question? All right, cool. 10y to the power of 5 divided by 2y to the power of 3. So I divide now. So again, I can take the 10 and divide it by the 2. You don't have to write it down, ladies and gentlemen. You can just write down what the answer of 10 divided by 2 is, which is 5, and get to work. So 10 divided by 2, writing it down. There's 2 y's, y5, y3. So I'm just write one of the y. The power of this 5 is 5. The power of this y, pardon me, is 5. And the power of this y is 3. I'm subtracting them. So why I subtract? Because the rules states that when you are dividing algebraic terms that have the same base, you're going to subtract the powers. That's the rule. So the answer becomes 5y to the power of 2. Any question? Okay,
Yes, sir.
cool. Question,
Yes, sir. We always subtract from right to left.
You subtract left from right. All right. Yeah. Right.
Okay.
There's
all
always
right.
this number over here.
So we always subtract
the number
where the 3 is, we always subtract that from the
number where the 5 is. Yeah.
yeah. Okay, good. Thanks.
Cool. All right. Now, here's what you can't do. And this is why I put that thing in. That's why I put that thing in green, you know. Because you're going to end up see this. 4x to the 4th times 3y to the 5. Now, this you can't. The only thing you can do is times the 4 and the 3. So the only thing you can do is say 4 times 3 is 12. And write back your x4 and your y5. Don't even think about adding that 4 and that 5. Look at what is in green. Same base. This is base x. This is base y. Don't interfere with the powers. Leave the powers alone. All right. Any question? Okay. Now, is it done? Is it that? No. It's not done. Just a start. So now, so I'm going to categorize them 3 groups. All right, look at this now. Come back over here. Let's say we end up with something like 5, oops. 5a to the 4th times 3a to the negative 7. Again, I'm not going to write down 5 times 3. I know the answer is 15. So get to work. And I write down back 1a, and I take the 4 and I add it to the negative 7. You see what is coming back at you again? Class number 1, when you just meet me. Integers is a reason why I teach that topic, you know. It's a reason I teach that topic because this integers thing just keeps haunting my students. This whole odd, it's going to happen to us. So what is 4 plus negative 7?
-3.
-3.
Very good. So the answer is 15/8 to the negative 3. Now the division is tricky, you know, because you're going to end up with some sign clashes. So you have to be very careful. I recommend, let me just circle it in red. I recommend, because some students them can't bother, you know, to go for writing today. You see that part here? I strongly recommend that you practice to write this thing down. Practice to write it down. And so if you don't want to write it down, make sure you know if you use a calculator. Because it's not like you're getting the marks for that, you know. And you're getting the marks for writing on the correct answer here. That's what you're getting the marks for. So when you show me this or you don't show me, you know, you can't get this answer down here unless this part up here is right. But if you're going to use your brain, like use your mental skills and mental mathematical skills, I recommend that you write that stuff down. I do it, you know, even at my level. I don't have to because I can do it in my head. But I still write stuff down. I lie. I don't do it. I lie. I joke me. I don't do that, guys. I'm way past the level here, so I do it in my mind. But I'm thinking that if I'm at your level, I want to write it down. All right. 25 t to the power of -3 divided by 5t to the 4. Guys, don't take show off. Show off bring disgrace. Do not take show off and try to subtract this thing in your head. You're going to get it wrong. Especially if you're not very strong at the integers. So what I do is that I recommend you say 25 divided by 5 is 5. Write down your t. Write down your -3. Your division say must subtract 4. Many persons would have just said the answer is 1. I'm sure somebody in here is thinking that, oh, -3 plus 4 is 1. Or -3 minus 4 is -1. Or whatever you guys are thinking. The answer is 5t to the -7. Sir, how -7? Look at it. This is -3. -3. The division evokes the subtraction sign. This is 4. That's 4. So it becomes -3 minus 4, which works out to be -7. All right.
Sir, me kind of lost what you're saying. You can just go back over it one more time, please.
Or put
25
it in
divided by
writing.
25 divided by 5 is 5. We get that part.
Yes, I get that part.
Write down back one of the t. What's the power of the first t?
-3.
What does the division ask us to do?
Subtract.
Subtract what?
The powers.
Right, which is the next 4 is what?
4.
So what is if I owe 3 and I owe 4? How much more in total?
7.
Right.
Oh, because me not see minus beside the 4 now. That's T. Kind of get me thrown off. Yes. Yes. Now, man, me see -3 here, so sir, but the 5t and the 4 there, so I'm gonna say no minus. So it's like,
because the minus came after division, you know, so it automatically
yes,
made for negative.
yes. I just realized what you're saying. I just realized. Thanks,
Yes.
thanks.
All right. So that's 5. Now, can it get any worse? It can. I wouldn't even say worse. It just can get to a level where this topic can bring out some. It can open up some old wounds. Because I have students who still struggle with fractions, right? It's not a bad thing that you struggle with fractions, you know. It's just that at this stage you shouldn't be. For example, let's say I gave you this one. Let's say I gave you this one. Simplify. I say simplify. Eight r to the half times 3r to the quarter, to the 1/5. And I said, well, simplify 8r to the half times 3r to the 1/5. People will think this is hard, you know. Yeah, people will think that this is hard. But in this class, we can't say this is hard. Because we know say 8 times 3 are 24. And we know we're going to bring back one of the r, and it's going to be a half plus 1/5. Now, at this stage, a student is not thinking about the fact that they have to find LCM. But you have to, it's fractions. So with this now, you have to go use and find LCM, which is going to be 10. 2 into 10, 5 times. 5 into 10, 2 times. 5 times 1 is 5. 2 times 1 is 2. The answer works out to be 24r raised to the 7 over 10. Yep. It exists. It's not that I'm going to give it to you. I'm just telling you that it exists. It exists. So you have to be open-minded to these kind of things that can come on the exam. And you're highly likely that you will see these things on the exam. All right. So what I'm going to do is that I'm going to give you 3 to try and give you 5 minutes. 3 to try, 5 minutes, and then we're going to advance. All right. Because we can go through all of these all day, all night. But if you aren't the one that is really putting your arms and hands into it, it's going to feel like you get it, but you don't really get it. So let us see if I can put you in a position to get some wrong and get some right. So go ahead for me, guys. 5 minutes to simplify the following. Simplify. What am I spelling? Disappeared. Simplify 1. 9x squared. Sorry, 9x to the minus 2 times 3x to the minus 4. Number 2. 12y to the minus 3 divided by 4y to the minus 5. Number 3. $15t to the 5 divided by 3t to the negative 2. So go ahead and simplify those 3 examples. I'm going to give you 5 minutes. Here you go. All right, so your time has expired. Let's see how you did. All right. So multiplication, 9 times 3 is 27. You grab one of the x's. This is minus 2 plus minus 4. You should have gotten 27 x to the minus 6. So 27x to the minus 6. If you got it right, thumbs up. 12 divided by 4 is 3. Grab one of the y. Minus 3. Division causes us to subtract. Minus 5. There's a clash. Hopefully you saw that clash. So when the clash occurs, negative by negative is a positive. So minus 3 plus 5 gives us 3y raised to the positive 2. If you didn't get 3y squared, it's because you didn't see the clash. So this division sign evokes a subtraction, and that subtraction clashes with this subtraction, giving us a plus. So we end up with minus 3 plus 5, which is 2. And 15 divided by 3 is 5. Grab one of the t. This is 5. This division sign evokes a subtraction. So that's going to be subtract 2. Subtract negative 2. There's a clash again. Negative by negative is positive. 5t raised to the positive 7. Let's see how the chat is looking. Who got it right?
Sir, it's a typo error. I did get the 3y, but I typed 12 here.
Hold on, you did get the 3, what? You put 12. Where's you put 12? How the chat looking? How the chat looking? Lamar get all of them. That's good. Alicia Garden get all of them. Well, people will not get them question right now. I don't think you guys understand the magnitude of skills that you guys are developing. You know, I feel like you don't think it's simple. So they'll be like, "Oh, sir, it'll go harder than this for exam." That's not the point. The point is that you're mastering it. No, could you have done it before tonight? No. If I gave it to you tonight, or you saw it on a paper, could you have done it? Probably not. Probably yes. Probably no. Got the first two, Simonia.
Yeah, sir.
Yes.
Yeah, I got the first two. So the last one. You can't go back over that because I have 12t minus 3. I know I'm the wrong this so.
Let's find out. So 15 divided by 3 is 5. And the power of the first t is 5.
Oh, me think I minus. Sorry, me never see the division. Me never see it.
Okay.
Never see the dot.
Yeah.
Yeah.
Yeah, that happened to me as well. I didn't see the
Oh,
dot.
so that's you're saying it right. 12,
So,
15 minus
yeah.
3. Oh, it's division.
Yeah.
Right.
All right.
I got that too.
All right. All right. So, you know, it doesn't matter if you get it right or wrong, or you get 2 right or 1 right. What matters to me is the principle. Because I'll do 10 questions and I'll get all 10 right. But if I know where the mistake is what's causing me to get all 10 right, the next time I try 10 more, I'm going to get at least 5 right. That's the aim. You don't have to get them right to say, oh, getting them right doesn't mean you understand. Getting them right means that you grasp the concept and you were able to do those questions. But I can put some more on the board that will challenge you. But we're not going to go there. We want you to, remain positive. All right? Now, we have 18 minutes left and I have 17% battery life. Let's see what we can do. All right, so is this going to come on the exam, though? Is this what we're going to see on the exam? No, I know that you're going to see. What? You think? Come on. I'll beat up, man.
Sir, sorry.
Yes.
Sorry to interject. How early are you gonna post this on the YouTube?
I can post it immediately, Even
All right.
tonight.
Okay, I like to go back over it.
Yeah, man, I can post it tonight and set it for release for tomorrow.
All right, no problem, because I have to go now. So I look at it.
Okay, no problem. Yeah. So beat not people. All of this here is what we call the fundamental understanding behind what you're about to see now. So what you're going to get on the exam is something that looks more like this. Simplify x squared y times, sorry, what's going on with my screen? So simplify 12x squared y5 divided, guys. So me throwing off all are going now. Divided by 4 x to the fourth y squared multiplied by 5x3 y9. So you look at that now and be like, no, sir. No, sir. This too hard. It really isn't. All I did was just put more terms there. Remember, I know, when we were doing it a while ago, all you had was just this and this. I never had so much letters. Did you have so much letters? I never had so much letters. How did it look? Let me see. Right, you only had one letter dealing with. So with this example, now you just have more than one letter dealing with. And so when students see this on an exam paper, this is what, can I give them the chills. All right, so here's up. So what we're going to do is take out the numbers, ladies and gentlemen. 12 divided by 4. I don't know if you want to write it down, if you're that type of student that needs to write step by step. 12 divided by 4 is 3. 3 times 5 is 15. And just take a little time and deal with the letters them one by one. First, x now. What's the power of the first x? Power of the first x, guys, talk to me now.
Two, sir.
2.
Good.
The first x is 2.
And the first division is what? Division calls us to what?
Minus, subtract.
So we go subtract. What we going to subtract? 4.
4, yes.
Because that's the next x, right?
Yes.
And then multiplication calls us to what?
Add.
What we going to add?
3.
The 3.
Right. Yes. Good. And then we grab the y now. What's the power of the first y?
5.
And again, division calls us to what?
Take away.
Are we going to take away what?
Take away 2.
Right. And then the multiplication calls us to what?
Plus 9.
Plus 9. You have a nice little setup this now. So your answer is going to be 15x and work out what numbers up there. 2 minus, you can use your calculator if you want at this time. 2 minus 4 is going to give us -2. -2 plus 3 is going to give us -1. Nari, -2 plus 3 is going to give us 1. 1, 1, 1. But do we write 1? No, we don't. If you want to write the 1, you can write the 1 here if you want to. It's up to you. That looks weird though. Now write it, look too funny. And 5 minus 2 is what? 3. And 3 plus 9 is 12. Answer. That's it. Yes, sir. You make it look easy. Because it is, guys. It is. It is. Same how you see me do it on the screen right now. Same how you do it on the exam. No different. It's going to look the same way. All right, let's flip the script. 15% battery life, 30 minutes to go. All right, let's look at this now. simplify simplify 5 a to the minus 2 b to the 7 times 4 a to the minus 6 b to the minus 3 divided by 10. Why do I like x so much? 10a, this is 6, guys, okay? 10a to the 5, b to the negative 4. So when the negatives are now there, it not give you only a spook, it give you a real spook. Be like, oh, the signs are going to give me problems. Let's see here. Let's zoom it in. All right, there we go. Let's grab the numbers them first, one at a time. Take your time. Numbers first. A is next, B is after. Simple. 5 times 4 is 20. 20 divided by 10 is 2. Very good. Grab one of the A's. We don't need all 3, just one. What's the power of the first A?
Minus 2.
What does the
Minus
multiplication?
2.
Yeah, what does the multiplication cause us to do?
Add.
What are you gonna add?
Add a minus 6.
Negative 6.
Good. Very good. And what does the division cause you to do?
Subtract.
What are you gonna subtract? The next A, the last A.
5.
Very good. B. What's the power of the first B?
7.
7.
What does the multiplication cause you to do?
Add.
So
Add.
You go add.
Minus 3.
Minus 3. And the division cause you to what?
Take away.
Subtract. What are you gonna subtract?
negative 4.
The 4.
Lovely. So now we know the answer is going to be 2a minus 2. At this stage, you don't have to use the O and have. Go on your calculator and type it in. Negative 13. And then this is 8. So check it. If you owe me 2 or you owe me 6, you owe me 8. You owe me 5 more, so you owe me 13. You have 7 or you pay me 3. So you have 4. And negative by negative is positive. 4 plus 4 is 8. Answer. That's it. No complications. So it does really people make it maths look hard. It's not really hard. Now, once you understand the principle behind it and what you're allowed to do, what are the rules, you're all right. You're solid. You're rock solid. And like I said, for CSEC, you're not really gonna get much challenge. With this year, this is just setting the foundation, right? So we have we learn, we carve out what we want, we think for day, we line it out, we put the foundation, we throw some cement, we're good now. We're all right. We know what to add and subtract. We know what we can't add and subtract. We know what to multiply, add powers. When we divide, we subtract powers. So you just have to just recognize the rules when them pop up and not the mean. And as usual, as I said, you can always go on ChatGPT. Where's my Google? Okay. You can always go on ChatGPT and ask ChatGPT to do the same thing. So you can ask it. So can you prepare? Come on. Can you prepare? Where is it? Okay. Can you prepare 10? We don't want 20. 10 multiplication, and division of algebraic terms modeled from the Csec math syllabus. And if you ask you that, it'll give you some general questions. You want to be specific, can you prepare 10 intermediate and advanced multiplication and division of algebraic terms modeled from the Csec syllabus. Boom. And there you go. There you go. Now, I like them one here still. I'm going to do some distribution. I like this. Can't work, but I like how this look. Yeah, but you get the idea. I'll probably find some for you and send it to you. Yeah? All right, ladies and gentlemen. We've done a lot tonight. I've done more than what I thought I could do. You know, we go through the basics and everything. So, lovely. All right. And you guys are good to answer B758. Okay.
Have a good
All right.
night.
After class, we will continue some more stuff on algebra on Sunday, and then call it a wrap. All right. Have a good night, everyone. Bye-bye.
Thank you, same to you.
You too, sir.